First, in motion, we'll talk about speed. We'll talk about speed. We'll talk about motion. What is speed? What is motion? We're talking about the basic things in physics today. So, we'll talk about what is initial velocity, final velocity, which is v, and acceleration. We'll also talk about time. We'll talk about deceleration. We'll talk about distance and so many more. For now, we want to look into this because there are some basic things you need to know for you to be able to solve problems on motion. Okay. As I mentioned earlier, talk about distance. Now, let's go straight to what is the meaning of speed. What is speed? If you were asked to define speed, what is speed? Speed is the distance covered over time taken. From the formula, speed is equals to distance over time. Okay, you need to know that because in solving questions, you can see as cheap as that. The opposite of I don't want to say opposite actually, but we have another one called displacement. Displacement has both magnitude and direction. We also have velocity. Velocity has both magnitude and direction. It's different from speed. It is the distance covered over time taken in a specific direction. That is velocity. So we also have many more that we'll be looking at in this place. Okay, for now, as I said, speed is equals to distance covered over time taken. Please like and subscribe, share this to your friends from other countries, other schools, share it to them, because in this place I'll release the 3 formulas that you can use to solve any motion questions, any questions on motion, you'll be able to solve it. Okay, let's continue for now. Now we say speed is equals to distance covered over time taken. For instance, now if I travel a distance of 5 meters and I use 2 seconds, that is going to be what? 5 divided by 2 will tell me my speed. And speed is measured in what? Meter per seconds, please. Meter per seconds. The reason for that is, remember, distance is measured in meter and it's over time. Time is measured in what? Seconds. So meter per seconds. Okay, so now we want to proceed now to the next question. What is motion? Motion is the movement that occurs from one place to another. If I say a body is in motion, I mean the body is moving. If it's no more in motion, that means it has stopped. A body is at rest. What is acceleration? Acceleration is the rate at which a body moves. Now let's talk about the 3 formulas that we use in solving motion. We have A is equals to V minus U over T, where the V is the final velocity and the U is initial velocity. A is equals to V minus U over T. And this could also be written as V is equals to U plus AT. Equals to U plus AT. If you make V the subject of the formula, this V here, if you make it subject of the formula, you have this answer. Now you're going to cross multiply. Okay, can you see that? AT is equals to V minus U. A times T. Then take U to the other side. And the minus U will become plus U. So U plus AT. Okay, that's for equation 1. Let me just call it equation 1. So I'm going to clean that now. And let's get to the second formula. The second formula is much more easier. It's S equals to UT plus half AT squared, where S is the distance, U is the initial, T is the time, A is acceleration, and T squared, no, that is time. So half equals to ut, and we have v square is equals to u square plus 2as. V is the velocity, u is the initial, v is the final velocity, u is the initial velocity. Okay, so these are the three formulas we'll be making use of in solving motion. Please, if you don't understand anything, please try to ask 1 or 2 questions. I'll be excited to answer you. Please share, like, and subscribe. Okay, now we're going to move with this question. A ball accelerates uniformly from rest at the rate of 3 meters per second square for 8 seconds. Calculate the distance covered by the body during acceleration. Now what you have to do here is to write out the parameters for that has been provided. Once you are able to write out the parameters and compare it to these 3 formulas, I bet you have done the right thing and you're going to get your answer if you solve it correctly. Now for here, now they gave us our velocity. No, not velocity, acceleration. Because a body accelerates, so 3 meters per second square. Even you can know that by using the unit. The unit for acceleration is what? Meter per second square. So A is equals to 3 meters per second square for 8 seconds. So the time is given, which is going to be what? 8 seconds. Yes, the time is given 8 seconds. And the body uniformly accelerates from rest. Then there is an initial, and from rest means the u is equals to what? 0. The initial is equals to 0. Okay, it's like I'm too fast. Okay, 8 seconds. Okay, and the initial is equals to 0. We also have distance there. Distance is not given to us. The distance is what we are looking for. Okay, distance is s. I understand. You can put as distance yours. And we have our initial to be equals to 0. So with this now, we're going to compare it with the formulas. So now distance is what we are looking for. Now they give us an initial. Say bodies accelerate uniformly from rest. That means the initial will be equals to 0 because the body at rest means it is not moving. It is at 0 position at that moment. When it moves, then we cannot see it move as 2 meters per second or 3 meters per second. But now it is at rest. So at this point, what we have to do is that we have to relate all these parameters to the 3 type of formulas we have for motion. Now any one of them that properly fits into this formula, that particular formula is what you're going to use to solve this question. But if it did not fit, then we don't use it. For instance, now we're going to compare these 3 formulas now. Is A equals to V minus U over T. Now, do we have acceleration? Yes, we have the acceleration there. Do we have velocity here? Final velocity here? No. So you can't make use of it. So we use the second formula. S is equals to ut plus half at square. The third formula says v square is equals to u square plus 2as. Now, let me come back to the first formula again. There we have A, acceleration, 3 meters per second square, is that not? V is final velocity. Do we have final velocity here? No. So this formula and these parameters could not fit into the first formula. So let's try the second formula and see. Distance, yes, we're looking for distance. We have it there. Initial, yes, we have initial, which is equals to 0. Time, yes, we have time, which is equals to 8 seconds. And we have A, which is acceleration, which is 3 meters per second square, and we also have time. So number 2 works. Can see I've marked it already, but the other 2 do not best fit into this equation because the other ones are final velocity, which we are not looking for. Okay, so we're going to use the formula S is equals to ut plus half at square. Now
in this kind of formula, I want us to be kind of mathematician, where we know that s and u is equals to what, 0, as we're written in the parameters, and t is 8 seconds, and plus half 80. 80, don't go and be putting plus a plus, no, times. What join them together is times. So times a is what, 3, times t is what, 8 square. Okay, so 3 times 8 raised to power 2. Yeah, then we're gonna solve that. 3 is with power 2. Okay, well, yeah, distance is equals to 0 times 8. Anything multiplied by 0 is 0, plus half times 3 times 8 square. Okay, times 3 times 8 square will give us 64. Okay, so now we can solve it to the next point. Now, remember I told you I'm going to be showing you 3 simple basic ways of solving motion. I'm going to show you the 3 simple things you have to know while solving motion, and those are the 3 formulas that we just revealed to you. With these 3 formulas, you can be able to solve any question. Despite that these questions are still simple, we'll still move to more technical questions in our next videos that we're going to be publishing. But for now, these contents that I've created are just the basic things you need to know while solving motion questions. Okay, now this next step to do is to uh, multiply these numbers together and get your final answer, which is measured in meter. So half times 3 times 64 will give us 192. 192 divided by 1 times 192 is going to give us 192, and 2 times 1 will give us 2, so it equals to 192 divided by 2. Okay, so we have 192 divided by 2. So 192 divided by 2, and that will give us 96 meter. So 96 meter is our final answer. So I have here 192 divided by 2, just equals to 96 meter. Please make sure you always write the unit while solving. If it is initial or final velocity, then you put meter per second. But if it is acceleration, you put, if you are looking for acceleration, that's meter per second square. Please make sure you always put the unit of whatsoever you are solving. It's very essential, so that you won't lose some important marks while solving. Next question. A body accelerates uniformly from rest at the rate of 4 meters per second square for 10 seconds. Calculate the distance covered by the body during acceleration. And here, acceleration is given to us as 4 meters per second square. The time t is 10 seconds, and we are asked to look for distance. And a body accelerating uniformly from rest, that is to say, that coming from rest, their initial is equals to what? 0. So u is equals to 0, and s is equals to, we don't know. So question mark. So we don't know what the distance there is equals to. So let's solve. Which formula works right? The first formula, or the second, or the third? Yes, the second formula go right with it. Why? S is equals to ut plus half at square. We are looking for distance. We have distance in the second formula. We are looking for, we have initial is also there. We have time is also there. We have acceleration is also in the formula, so that is the best formula for it. So S equals to ut plus half at square. Put the right parameters. That's 0 times 10 plus half times 4 times 10 square. 0 times 10, that is 0, plus half times 4, that is 2, 10 square, that is 100, 2 times 100, that is 200. So our final answer should be 200 meter. Okay, so half times 4 times 100, so this is going to be 200 meter. So distance they are looking for is 200 meter. Let's proceed to the next question. How far will a body move in 4 seconds if uniformly accelerated from rest at the rate of 20 meter per second square? Okay, now we are giving time to be 4 seconds. We are giving acceleration to be 20 meter per second square. Now they're asking us how far, that is distance. How long will it be? What meter? Okay, so we're looking for distance there. So now what formula will go for where we go? Remember that they say accelerated from rest. The rest there means they have given us our initial, which is equals to what? 0. Okay, initial is equals to 0 because they're asking us how far. So now distance, how far means distance, which is equals to, we don't know it yet. Distance covered, we don't know what is the distance yet. Now what formula work very best for this? Is it the first formula, the second, or the third? Which of them has both seconds, that is time, acceleration, initial, and distance? We all know that the second formula. I've already written it already. So 0 times 4 plus half times acceleration, which is 20, times time, which is 4 square. So 0 times 4 is 0, plus half times 2, 20 is 10, 4 square, that is 8, no, that's 16, 16 times 10, that is 160. So the final answer here is 160 meter. Okay, so now this is how you should be able to solve each question on motion. Though these are very simple ones, we'll still be proceeding to the more technical questions, but these are the basic things you need to know while solving motion in physics. Okay, next question. A bus traveling at 50 meters per second accelerates uniformly at 4 meters per second square. What is the distance covered in 10 seconds? Write out the parameters where our initial is 50 meters per second. This time it is not 0 because it's not accelerating from rest, rather is accelerating from 50 meters per second. That is first velocity, and that is the initial, which is 50 meters per second, and the acceleration is 4 meters per second, and the time given to us there is 10 seconds. And what we're looking for is distance. What formula are we going to still use here again? Is it the same formula? S equals to ut plus half at square. So in this question now, what we did mainly in this question is using that formula, S equals to ut plus half at square. I believe you should be able to know how to solve this by now. Now input the right values into the equation, where u is 15 this time, times time there is going to be 10, plus half times 4 times 4 times 4 times 2 square, which 2 square is 10 square. Okay, 10 square. 15 times 10, that is 150, plus half times 4, that is 2 times 10 square. Okay, that's like 200. Okay, 10 square is 100, 100 times 2, that is 200. Okay, so 150 plus 200 gives us like 350 meter. So final answer for here will be 350 meter. Okay, I'm solving it again. Half times 4 times 100. Okay, so let me clean that one. Let's just go to 400. So 4 times 100 will give us 400. Okay, so from here we have 150 plus half times 400, that's 200. So 150 plus 200. So 150 plus 200. 150 plus 200, that's 300. That is going to be 350 meter. Please, in this question, I want you to like and subscribe, share this video. We are coming for more physics question. Do you have any question related to JAM? Do you have any question related to WIAC? Please feel free to ask us in the inbox box below, and don't and please make sure you keep up to be up so as to be updated about this video once we listen